today we're presenting the Interledger Protocol internship project. So yeah, I think you can start.
Okay, sure. My name is George Roman, and I'm a Hyperledger mentee working on integrating Hyperledger Iroha with Hyperledger Quilt, or more specifically integrating Hyperledger Iroha with the Interledger Protocol, because Hyperledger Quilt is just an implementation of the Interledger specification. So today I will give you a short overview of what exactly is Interledger and then show you a demo of the integration that I've done so far. So Interledger is a standardized protocol that aims to enable the secure transfers of funds across any two ledgers. So let's assume that some user that we will call the sender wants to transfer funds to another user referred to as the receiver. Have they both accounts in the same ledger, this action would be straightforward. Just transfer the money on the underlying ledger and you are done. In our scenario, however, they maintain accounts in separate ledgers, A and B respectively. So in this case, the transfer can be facilitated by a third user called a connector in Interledger terms. And this connector could be, for example, a bank or a financial service provider. And this connector maintains accounts in both ledger A and ledger B. The idea is that the sender will transfer funds to the connector in ledger A, and the connector will transfer the respective amount to the recipient in ledger B. The amount reaching the recipient will depend on the amount paid by the sender, obviously, as well as the connector's exchange rate for conversions from A to B, and also its service fee. The sender is able to make payments by sending Interledger prepare packets, while the receiver responds with either ILP fulfill packets, acknowledging the receipt of funds, or ILP reject packets in case of errors. One could say that this is not at all secure since it involves performing two separate transactions. Interledger overcomes this issue by using multiple low-value transfers, that is micropayments, that minimize risks, together with having the connectors set up bilateral trust relationships with each other. This still involves some risk, but it's confined exclusively between directly interacting connectors, and it typically concerns small values, because each connector can decide on how much risk it's willing to take. So let's go more in depth into this, because this is the essence of the Interledger protocol. So connectors clear and fulfill Interledger packets with their peers, and these represent conditional IOUs, that is unenforced debt, which affect financial accounting balances between the peers. These balances, however, are at the Interledger protocol level, and they don't reflect the balances of the peers on the underlying ledgers. That is, at the Interledger protocol level, money is actually not moved, meaning that ILP doesn't decrease or increase the total amount of electronic money in circulation. As the connector receives incoming ILP prepare packets from a peer, forwards them and returns corresponding ILP fulfill or ILP reject packets, that peer's liabilities to the connector accrue. If the peer's liabilities exceed the credit limit that the connector assigned to it, the connector may reject and decline to forward additional packets. In order to continue transacting, the peer must settle their liabilities. This is the step where the money is actually moved. This is accomplished by sending a payment on the underlying ledger that both peers have agreed to use. The connector should credit the incoming payment, irrevocably discharging a sum the peer owes to it, which enables it to clear subsequent Interledger packets from the peer. So by assigning credit limits to the peers it transacts with, a connector or sender or receiver is able to minimize risks while at the same time supporting fast micropayments. And next, I'm going to show you an example of performing a payment across two different Iroha blockchain. So here I have a Docker Compose file, which is used to set up all the required processes in order to run this example. So we can see that we have two Iroha blockchains, Iroha 0 and Iroha 1. We have three interledger connectors or interledger nodes. We have Alice, Bob, and Charlie. And in this example, Alice will send some money to Charlie, and they both reside on different Iroha blockchains. And next we have some settlement engines. And the settlement engine is a service that is used by the connectors to actually transfer the money on the underlying ledgers. And settlement engines are required to provide a standard interledger API so that connectors can use the same API in order to perform the settlement, regardless of the specific details of the blockchain that the payment is made on. So with all said, I have here the Docker Compose file running, and I will run the example. I will also talk about it step by step. So we have Alice, Bob, and Charlie. Alice wants to send some money to Charlie. However, they reside on different Iroha blockchains. So they can't just use direct transfer on the same blockchain because they are not on the same blockchain. So in this case, Bob has accounts on both blockchains, and Bob will facilitate the payment between Alice and Charlie. So running the example, we first just deposit some assets into Alice's account and Bob's account. Next, we query their balances. We see here that on the first Iroha blockchain, Alice has 1,000, Bob has nothing, Charlie has also nothing. Charlie doesn't even have an account on this blockchain. On the second blockchain, we have Bob that has 1,000, Charlie that has nothing, and Alice also doesn't have an account. The next steps are for setting up some accounts between the parties that are involved in the transfer of money. At this step, they usually exchange ledger identifiers to know who to transfer the money to when doing the settlement. Next, we need to inform the connectors about the exchange rates for the currencies that are being exchanged. And now the last step is to actually perform the payment from Alice to Bob. And finally, we query the balances again, and we can see that Alice now has 500, while Bob also has 500. And again, this is on just on the first Iroha blockchain. So we can conclude that Alice transferred 500. Initially, Alice had 1,000. He transferred 500 to Bob, while Bob transferred 500 to Charlie on the second Iroha blockchain, because initially Bob had 1,000 and Charlie had nothing. So my work for integrating Hyperledger Iroha with the Interledger Protocol was to build a compliant settlement engine for Hyperledger Iroha. And I've also tried to generalize the implementation as much as possible. I've also added in the implementation some abstract Java packages that could potentially be reused for any other settlement engine implementations for other blockchains. And my work is open source. You can find it on GitHub. So yeah, please let me know if you have any questions.
I have one question. Could you provide a link to the GitHub with your code?
Yeah, sure.
Yeah, maybe we could also have some comments from Yuri, who is the mentor for this project.
Everything was great. It was a great project. Thank you, George.
Okay, so yeah, any other questions?
So another question is if this integration will also work with transferring between, for example, Iroha and Ethereum. It's one question, and another, if are those tokens convertible to ERC20?
Yes, Interledger could be used for transferring money across any two ledgers. I've also set up an example for transferring money from Hyperledger Iroha to Ethereum. That works. Basically, it's just a matter of having a settlement engine implemented for the specific blockchain that you want to use in your payment. And yeah, it could be used for ERC20 tokens. I mean, it can be used for any tokens, not just native blockchain tokens.
Another question. Because as I understand you correctly, this integration is finished and can be used. Are any instructions how to do this publicly available or not yet?
In my GitHub repo, there is a folder examples that contains some README files explaining how the examples work. You can also go through Docker files. For example, I have scripts that you can go through. Those have comments, so it should be explained there.
Okay, and now it's working with Iroha version 1.2 or also 1.1?
At the moment, it's working with Iroha 1.2. That's what I've tested it with. I couldn't test it with Iroha 1.3 because there were some issues with the Java bindings for Iroha 1.3. But once that is fixed, yeah, it should work.
Okay, any more questions? I see that new people join us here, so.
So I want to probably ask from the Iroha side. So George, you said that we are going to break the transactions into the smaller pieces, and what do you think how it will influence the kind of the performance of the overall operation?
Well, that is more an Interledger concern, because that is done at the Interledger level, and I've mainly worked with the settlement engine implementation. The Interledger infrastructure, meaning the connector, was already implemented and is implemented by and is maintained by the Interledger team. However, that shouldn't be the case.
Obviously, we are doing kind of more transactions, right? So, so more transactions will influence the performance. So probably just interesting about the benchmarks or something that probably they have or that you probably tried.
Yes, they are making more transactions, but those transactions are only at the Interledger level. So for each micropayment, you don't necessarily need to make a transaction on the underlying ledger. You just send packets of money to the party that you transact with, and that means that you are indebted to that party, and that party can assign you a credit limit. And once you go over that credit limit that the party assigned to you, you must perform a transaction on the underlying ledger. Does it make sense?
Okay. And talking about the risks, these risks, can you elaborate a little bit more so about the risks that we have related to these transactions? So why do we need to drop them into the smaller ones?
Well, using micropayments is much faster, and yeah, there are some risks in the Interledger approach, meaning that basically you can send money to someone and the amount that you send to them doesn't exceed the credit limit that they assign to you. In this case, you don't have to make a transaction on the underlying ledger. And in the end, you might not even pay those money because Interledger doesn't has any mechanism to force you to make the payment on the underlying ledger. However, the party that you transact with should assign you a credit limit so that the risk is minimized. If they trust you enough, they should assign a higher credit limit. If they don't trust you at all, they might assign you a very small credit limit, so that for any payment you send, you also have to send an underlying transaction.
But I'm asked about this risk related. So why we are kind of making these small transactions about this one? Because probably it's not so clear. So why we need to divide?
Well, let's say that we wouldn't divide and we need to send 10 ethers to someone. We send 10 ethers at the Interledger Protocol level, and we don't make that payment on the Ethereum blockchain, on the underlying blockchain. Those money could be lost.
But if we are making this smaller, because we, even if it broke down into the smaller transactions, right? So we still can not do this underlying ledger transaction, right? So probably
but the amount is much smaller, so the risk is much smaller. So for example, we could say that once someone sent us, I don't know, 0.01 ethers, they have to make an underlying transaction on the underlying Ethereum ledger, or else we won't receive any payment from them.
Okay, thanks.
So I have another question. So is it possible to disable this transaction, this credit in your implementation, or no?
Yeah, actually this configuration is at the connector level. You can configure your connector as you want. You can even remove the credit limit you assign to parties. So yeah, for example, for connectors that are in the same organization, we could simply ignore the credit limit because we trust the peers that we transact with. So that would be useless in that case.
Could you repeat maybe this issue? You told this in the beginning, but I'm not sure if I understand this correctly. So if we remove this credit, no credits, let's say, during transfer. So what are risks when we don't have any credits in transactions?
Well, if there are no credits in transactions, then it means that we have no transfers on the underlying ledger. So we have no money transferred on the underlying ledger. We only have transfers at the Interledger Protocol level. However, if we want to use those money on the blockchain, then we can't. So the credit limit is used in order to force the party that you transact with to send money on the underlying ledger to perform settlement. Because if that doesn't happen, that means that we don't have access to the money on the underlying ledger.
One more question. Let's say somebody is trying to send from one Iroha network to another. Let's say Bob to Alice, but Alice doesn't exist in another Iroha network. What would happen? Money will come, or tokens will come back to sender, or what?
The transaction will fail because initially, in order to perform the payment, the parties need to exchange ledger identifiers, meaning the identifiers on the underlying ledgers. Since Alice doesn't have an account on an Iroha ledger, the setup step can be done, so the transaction will fail.
Thanks for all answers.
No worries.
If there are no more questions and no more topics to discuss today, I would like to thank George for the presentation and Yuri for this project, for mentoring this project, and to wish you luck on the Hyperledger internship presentation. So
thank you.
I'm pretty sure everything will be great. And yeah, thanks everyone for joining. Oh yeah, the link to the repository. George, are you in the Iroha community chat?
in the Telegram group chat?
Yeah, Telegram.
Yeah, I will provide the link right after this meeting. Sure.
Yeah, awesome. So yeah, the link will be there. And yeah, thanks everyone for joining, and have a good week. Stay safe.